there may be other intelligent civilizations capable of communicating with us. The impact on ourselves of contact with another intelligent civilization is now being discussed by serious thinkers the world over.
It seemed to me just perfectly natural that we would not be the only manifestation of life in the cosmos.
Out there is a million other civilizations, and they're all a lot smarter than us.
We now know without a doubt that the possibilities for life are literally innumerable.
And we haven't begun to look. We have way more places still to go.
So we take very large telescopes and we point them at nearby stars or nearby galaxies and look for that special kind of radio signal that we think is only produced by technology.
It's time to commit to finding the answer to search for life beyond Earth. We are live, we are intelligent, we must know.
We are literally doing an experiment to find out what the answer is, rather than doing what we've done for millennia, which is to ask the priests and the philosophers what we should believe about life beyond Earth.
Dr. Jill Tarter is part of a movement known as SETI, the Search for Extraterrestrial Intelligence. She's dedicated her life to it. She's also the inspiration behind Jodie Foster's character in the sci-fi movie Contact.
So if it's just us, seems like an awful waste of space.
Today, SETI is a mission involving scientists from around the world.
So what SETI searches look for is electromagnetic radiations like radio light that is different than the radio signals that we get from natural objects like stars and galaxies and quasars, and consistent with the kind of light or electromagnetic radiation that's produced by technology.
Andrew Simeon heads up a team at Berkeley University.
We're up to 8.8 petabytes at Green Bank, right?
For 10 years, they'll be scanning the cosmos as part of a $100 million privately funded initiative.
Technological sources have a very interesting property, which is that they can compress electromagnetic energy in time or in frequency. So you can have a lot of energy, a lot of radio energy at just one place on the radio dial, and that's something that nature doesn't tend to do.
The team's work is the most comprehensive search ever undertaken in nearly 6 decades of SETI efforts. And technological advances mean that the search is finally building momentum.
What we've done for a number of years is to go to a large radio telescope, presumably a national facility, and rent time, or figure out a way to piggyback on other people's observations. And so we wanted to get to a situation where we were doing SETI 24/7.
290 miles northeast of San Francisco is the Allen Telescope, a cluster of small dishes dedicated in large part to SETI research.
The Allen Telescope Array is the first time we've ever built a large radio telescope out of a lot of small dishes. The joy of having small dishes is that they look at a large area on the sky all at once. Ultimately, we'd like to have 350 of these 6-meter dishes here. Right now, we have 42.
Alongside more telescopes, more powerful computers offer a chance to expand the search. The quantity of data produced is staggering.
With our next generation of radio telescopes, we'll be ingesting as much data from just one telescope as is coursing through the entire internet at any given second. So we collect a massive amount of data from the telescopes that we observe with, and some snippets of that data are actually brought back to our lab here at Berkeley. There's this gradual roll-off. We actually have to look for the sorts of signals that we're trying to find. And to do that, we develop powerful algorithms, including algorithms that use things like machine learning and artificial intelligence.
Scientists now know that most stars have planets. Jill Tarter believes this radically increases the chances life is out there.
When I was a graduate student, we knew about 9 planets, those in our solar system. But we didn't know about planets around other stars, not at all. Today we know that there are more planets out there than stars. Every star has, on average, at least 1 planet, and usually more. So that is a huge game changer. The universe seems a lot more potentially bio-friendly, and now lots of people are interested in the question of life beyond Earth.
There are more stars than grains of sand on all the beaches of the world. If you look at one of these grains of sand and say that's the sun, and the third planet around it's habitable, and you look at the beach, I mean, how could it happen in one grain of sand and not in others? So we're very optimistic about SETI. It's probably just a matter of us being able to recognize what a very advanced civilization would look like.
Lawrence Doyle was part of the NASA team that used the Kepler Space Telescope to hunt for planets outside our solar system, but now he's bringing the search back down to Earth.
There are various kinds of intelligence, but the one that SETI is going to detect is going to be communication intelligence. Everything communicates. All animals and even plants communicate. It's just a matter of how complex is that communication. I thought, well, why aren't we studying non-human communication on Earth? So, as a proxy for an extraterrestrial signal, we proposed, starting with bottlenose dolphins and humpback whales and squirrel monkeys, to kind of design an intelligence filter for SETI so that we can recognize the general rules of intelligence. So we've devised various ways of looking at a signal, a message, and analyzing how complex, what the relationships are between signals. In human linguistics, the relationships are called syntax. If you're missing a word, you can recover it. If you're missing 2 words in a row, you can still recover. 3, you can see it gets harder. If you go up to 9, there's still a possibility you could fill in those words, but there's very low connection. If you're missing 10 words, you might as well just guess a word from the dictionary. So we go up to 9th order entropy. That is, there are still connections 9 words away of grammar and syntax. All animals, all people, all extraterrestrials, they have to follow these rules if they're transmitting knowledge to each other. And if and when we get a message, we can recognize the complexity of that communication system. We can say, okay, we go up to 9th order entropy, word entropy. Squirrel monkeys probably go up to 2nd order. Humpback whales, we don't know yet. We haven't got enough data. Extraterrestrial signal comes in and they go up to 20th order entropy. And we are going to know that their communication system is to ours as ours is to squirrel monkeys.
We are connected to this huge cosmos, and we want to know what else might have evolved out there.
Were we to know for sure that the universe actually many, many times has given rise to some sort of organism like us that thinks and asks questions about the universe itself, I think it could very much change our perspective on science and our perspective as humans. And I think the ultimate outcome of that change in perspective could be truly, truly amazing indeed.